this is lesson 5-6, inverse variation. Many people think that inverse variation is the exact opposite of direct variation. In some ways this is true, and in some ways this is not. Inverse variation is similar in some ways, but it is quite different in others. Inverse variation is an equation in the form of xy equals k, or y equals k divided by x, where k cannot be 0. The constant of variation for inverse variation is k, just like it was for direct variation. The product x times y for an ordered pair of x, y gives you the constant of variation of k. Inverse variations have graphs with the same general shape. Direct variation is a linear graph that will go through the origin. An inverse variation is not a linear graph. It's a graph that has basically the same shape. Most of the time, an inverse variation graph will look something like this. Because basically, an inverse variation graph tells you that something is varying inversely or proportionally with something else. As one value goes up, the other value goes down. An example of inverse variation is the more miles I drive, the less gas I have in my gas tank. As the number of miles increases, the amount of gas in my gas tank decreases. That's what we would consider to be inverse variation. One value goes up while the other value goes down. Now, if we wanted to do some things to write some inverse variation equations, we write inverse variation equations similarly to how you write a direct variation equation. You solve it the exact same way. You just have to remember that the equation for inverse variation is xy equals k rather than y equals k times x. So suppose y varies inversely with x and has the following points on the graph. We're going to write an inverse variation equation. Okay? So if we have an inverse variation equation, remember the inverse variation equation is xy equals k. That's inverse variation. So the first thing we need to do is we need to find the constant of variation. Again, we already know what x and y are because it told us right here x is 2 and y is 9. So I can replace x with 2 and 9 with y, and that's going to equal my constant of variation. 9 times 2 is 18. So my constant of variation is 18, and my equation of variation then would be x, y equals 18. There's my equation for inverse variation. For the next problem, we have the x and y. They just happen to be written as a coordinate point rather than x and y. So 8 is the x and 9 is the y. So we have 8 times 9 equals k. So 72 equals k. So my equation of variation is x, y equals 72. The last question here, they give you the fractions. You have to remember how to do fractions. Remember, multiply straight across the top, straight across the bottom. So if we're going to multiply x times y, we're going to have 3/5 times 1/10. That's going to equal k. Straight across the top is 3, straight across the bottom is 50. So k equals 3/50. So my equation would be x, y equals 3/50. As simple as that. That's how you write the equation of inverse variation. Now, suppose x1, y1, and x2, y2 are two ordered pairs of an inverse variation versus a direct variation. Each ordered pair on an inverse variation has the same product k, that x1, y1 equals k and x2, y2 equals k. So x1 times y1 has to equal x2 times y2. So each pair of points if you're told that each pair of the following points is on the graph of inverse variation, you have to find the missing value. You're simply going to plug into this equation right here, x1, y1 equals x2, y2. And simply put, if it makes it easier for you, you can say that this is x1, this is y1. This is x2 and this is y2. So I can simply put in x1 times y1, 5 times 6 is supposed to equal 3 times y. 5 times 6 is 30, equals 3y. Divide by 3. So y has to equal 10, and that's my missing value. That's what I was supposed to find. The second example here, x1, y1 equals x2 times y2. So 3y equals 45. Divide by 3. y equals 15. That's my missing value, 15. Last but not least, we can do x1, y1 equals x2, y2 here. We have 75 times 0.2 equals 3 times x. 75 times 0.2 is 15. 15 equals 3x divided by 3, and x equals 5. Actually, inverse variation is a little simpler in many ways than direct variation is. All right, let's look at the difference between direct and inverse variation. Let's look at the graphs that we have here. If you look at these first two graphs, you'll notice that the graph goes through the origin and it's linear. It goes straight up and down. It's either increasing or in this case it's decreasing. But you'll notice as one value increases this way, this value increases this way. As x got bigger, y got bigger. Over here on the second graph, as x gets smaller, because going smaller is going left, y is also going smaller. Right? Right? So it's just the same thing that you're looking at. It's changing that way. It has to go through the origin. Y is directly proportional to x. The ratio is going to be y over x. In an inverse variation, as you can see, it's y equals kx or xy equals k. Y varies inversely with x. So as x is increasing, notice as these values go up, this value is going down. Y is going down as x is going up. As x is going down, y is going up. So they end up to be little curves like that, smooth little curves. Now, we can decide if each data in a table represents direct variation or inverse variation. Okay? Remember, if it's direct variation, okay, direct variation, you will have y over x will equal a constant. And in inverse variation, okay, in inverse variation, you will know that xy equals k. Okay? So, if we're going to look at something, we're going to compare your x and y values. Remember, inverse variation, one value goes up, the other value goes down. In direct variation, one value goes up, the other value goes up. So it seems like they should be the same, where one value goes down and another value goes down. If we look at this, as x is going up, that's increasing. Y is going down, decreasing. So it looks like it might be inverse. Right? It looks like inverse variation. So let's see if it actually is inverse variation. If it's inverse variation, x times y should stay constant for all my points. Okay, so let's look at this. 3 times 10 equals 30. 5 times 6 equals 30. 10 times 3 equals 30. So obviously x times y equals k. It is inverse variation. In this particular case, this is an inverse variation. And the equation would be x, y equals 30. If we look at the second table, where x is 2, y is 3, x is 4, y is 6, x is 8, y is 12, x is increasing, it's going up. Y is also increasing, going up. So it looks like it might be direct variation. As one value goes up, the other goes up. Okay? So we're going to check to see if the direct variation applies. We're going to see if y over x is constant. So y over x, 3 over 2, 6 over 4, and 12 over 8. Right? 3 over 2 reduces to 3 halves. 6 over 4 reduces to 3 halves. 12 over 8 reduces to 3 halves. So all of those reduce to the same ratio. So this would be direct variation. And the equation would be y equals 3 halves x. Simple as that. So to tell if something is direct or inverse variation, you can look at the graph. And if you can't tell from the graph, you should be able to look at a table, and the table can can be evaluated to see if it is inverse or direct variation.